Hi everybody. So this is 10.2 power to a power rule, and it's a lot more of what we've been learning so far. Okay, so first thing, I just want to do like a quick little review of what we've done so far. Okay, is we've talked about how if you have a to the second power times a to the third power, if we had those, exponents are the same base. Sorry, exponents are different, but we have the same base. If you're multiplying them together, what you can do is add those exponents together and you get a to the fifth power. So that was the big idea from the last lesson that you guys learned. Okay. So the big idea now is we're doing this thing called a power to a power rule. So check this out. Let's say you have something like 2 to the third power. Okay. And you're trying to figure out, what is this? Well, what exponents are repeated multiplication. So really this is just 2 times 2 times 2. Okay. Now the question is, what happens if we do something like this, where we've got 2 to the third power inside parentheses, and we raise that to the second power? What do you think it means? Got your guess yet? Okay, so same kind of concept. We have this base on the inside of the parentheses, and an exponent means repeated multiplication. So we're doing 2 to the third power, and we're repeatedly multiplying it 2 times. So this is 2 to the third power times 2 to the third power. Okay. The 2 to the thirds were the number inside our parentheses, and this exponent of 2 means we multiply it together twice. So since they have the same base, this is why that last lesson was so important. We add the exponents and we get 2 to the sixth. And this is true for anything inside parentheses with the exponent on the outside. So the power to a power rule. Okay. The power to a power rule states that if you have a to the m power on the inside of parentheses, and you have a to the n power on the outside, okay, this becomes a to the m times n power. If you have two exponents, one on the inside of parentheses, one on the outside, you can just multiply them together. So let's do a couple examples. The first one you already saw was the one on the previous page. Let's say if we do 3 to the third power times 3 to the second. Okay. So really that's 3 to the third times 3 to the third, which equals 3 to the 3 times 2. Okay, multiplying these little powers together, and we get 3 to the sixth. Another example would be something like if you have negative exponents. If you've got 2 to the third power to the negative second, okay, same thing, you have to multiply the exponents. So this becomes 2 to the negative 6. And 2 to the negative 6 becomes 1 over 2 to the 6th power. Okay, that's another thing we learned the other day. If you have a negative exponent, you have to switch it across the fraction bar. Okay. So those are some examples of a power to a power rule. Okay. Another one would be if you had like a fraction. So if you've had 3 to the 5/2 power to the second. Remember, you're multiplying these exponents because of the power to a power rule. So this is 3 to the 5/2 times 2, or you can say it's 2 over 1. 5 times 2 is 10. 2 times 1 is 2. And 10 divided by 2 gives us 3 to the 5th power. So just getting used to those things. Okay, next thing we have on our agenda is this thing called raising a product to a power. Okay. So let's say, for example, you've got 2 times r to the 3rd power. You have a product in the parentheses, meaning you have some kind of multiplication going on, and you have an exponent on the outside. That's our power. Okay. So repeated multiplication, the exponent says that we're going to do 2 times r 3 times. So you got 2 times r times 2 times r times 2 times r. So 2 times 2 times 2. We can reorder these to put all the 2's together. So I'm going to switch the 2's around. This is 2 times 2 times 2 on the left. We simplify all the exponents together. So r times r times r. And 2 times 2 times 2 is just 2 to the 3rd. R times r times r is r to the 3rd. And this is our expression completely simplified. So do you see a pattern from the very beginning, the very first problem we have, and our answer? You should start to see something. Okay. When you have two numbers being multiplied in the exponent, these powers need to come down and they apply to both of them. It's almost like distribution, not quite. This is the product to a power rule. Let's do another example. Okay. What if we have 3 times a to the 3rd power squared? So again, we have a product in the parentheses. The 2 means we're going to multiply what's inside the parentheses together twice. So this is 3 times a to the 3rd. That's 1. And 3 times a to the 3rd. That's 2. So there's where our exponent of 2 goes. So we can reorder this. We can swap these guys around because of the commutative property. This is 3 times 3 times a cubed times a cubed 3 times 3 is equal to 9. Sorry, because we're trying to stick with our simplification here. 3 times 3 is just 3 squared. A to the third times a to the third. Again, we combine these exponents, and this is a to the 6, which comes down to 9a to the 6th power. Okay. But really what I want you to focus on is right here, looking at this simplified expression and the original problem. Again, this exponent came into the 3, so 3 to the second came here. And the 2 also was multiplied to the other product of 3. So 3 times 2 gave us this exponent over here of 6. Okay. We also have scientific notation we gotta talk about. Scientific